I said that I would do handout number 17 in a video, so here we go. This is the one from class on Thursday, 11, day after election day, so 11/5. Okay, and so the first one is to show that the tangent of theta is equal to sine theta over cos theta. And I'm going to use a picture here. And we're going to think of theta, here's x, y, and h. So sine is opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse, so x over h. So when I divide sine by cosine, I get y over h over x over h. To clear the fractions, I cross multiply, so I mean invert multiply, so I flip the h and the x. Those h's cancel, and I get y over x, which is the tangent. Opposite over adjacent. Okay, that was one of the ones. Okay. So the next one is to show that sine squared theta plus cosine squared theta is equal to 1. Okay. So here we go. We know that in this right triangle, x squared plus y squared is equal to h squared. Okay. Now the sine squared is going to be y over x squared. The cosine is going to be, the sine is going to be y over h squared. The cosine is x over h squared. So I just need to show that I get 1 here. So I'm going to get y squared over h squared for the sine. For the cosine, I get x squared over h squared. Now, that's going to be equal to x squared over y squared over h squared. Now, notice I go back over here. What's x squared plus y squared equal to? Well, that's equal to h squared. So I just put h squared here, and I get that over 1. Okay, so I'm going to repeat something about this. This is very important. So, and I also want to clear up something about notation. This is called the Pythagorean theorem for trigonometry, and it's essential. It's super, super important. And when if you apply this or take calculus, you'll see this over and over again. And we'll see it later in the course. And by the way, this is the standard notation. Notice where the exponent is for this. And people will interpret this, if you put the square there without the parentheses, as this. And so will your calculators. So really, that's the preferred way to write it. Do not write it this way, because it can be misinterpreted. Okay, so for 3, we want to write all the trigonometric functions in terms of sine and cosine. So, so we have 6 of them. We have sine, cosine, tangent, cosecant, secant, and cotangent. Now the sine is already written in terms of sine. The cosine is already written in terms of the sine or cosine. The tangent we just saw was equal to sine over cosine, so that's done. The cosecant is equal to the reciprocal of the sine, so that's done. The secant is equal to 1 over cosine, so that's done. And the cotangent is the reciprocal of the tangent, so that's 1 over sine theta over cos theta. We invert and multiply 1 times cos theta over sine theta, cos theta over sine theta. So again, everything can be written in terms of sine and cosine. And again, this if you take a course where you apply trigonometry, this kind of thing gets used. Okay. So the last problem on the handout was to just do a few simplifications. And so we had, the first one was secant theta times sine theta. and this is 4a. So the idea is to simplify it. You want to write everything in terms of sine and cosine, and then simplify. Secant is 1 over cosine times sine. That simplifies to sine theta over cosine theta, and that's going to be tan theta as we saw in problem number 1. Okay, so that's kind of what, for these kinds of problems, that's what you do. So now we have cosecant theta times cos theta. And again, I want to write secant theta in terms of sine or cosine. So I go back, and that's 1 over sine. Sorry, you can't see that. So I'm going to use that. And that's times cosine theta. That simplifies to cos theta, tan theta, and that's going to be cotan theta. Now we know it in two ways. One, we look at the tangent here, and we just see that that's the reciprocal. Or we can look back to what we just did in the problem of cotan theta equals cosine over sine. So we got two more. We got tangent over cosecant. That was 4b. For c is to simplify tan theta over cosecant theta. So tan theta, as we saw, you can look up there and see it is sine times cosine. Cosecant is 1 over sine. Those cancel. And we're left with 1 over cosine. Now that should be familiar, so you go back, let's look on the page we just did. 1 over cosine, that's secant. So this ends up being the secant theta. And we got one more, 4d, that's going to be cotangent theta times sine theta. And you can see it's going to be similar probably. Cotangent, we know from here, is cosine theta over sine theta. Sine theta is just sine theta. Those cancel, and we're just left with cosine theta. So these kinds of things are commonly done. Sometimes you do a computation and you have to simplify things. One way to simplify things is to just turn it always into a sine or a cosine. Work with that, simplify that, and then go back and figure out what you got. Okay, so that's 17b. The last problem was to graph sine, cosine, and tangent, but we covered that in the videos. I kind of had hoped we'd go over some of that in class, just so, when we looked at the videos, you'd have a little bit more to draw upon. Okay, well, that's it. Thank you.